Welcome to the lectures on problem solving and programming in C. This is lecture 13, and the title of the lecture is Extracting and Counting Digits. Suppose if you have an integer number, how do we count how many digits the number has? Or how do you extract the digits one by one? So these are the basic problems on numbers. So how do you count the number of digits? For example, suppose if the number of suppose 1 2, if you have 1 2 3 4 number, then how many digits it says? Number of digits is equal to 4. So suppose if you want to extract the digit from right to left means this direction, so you will have 4 3 2 1. Suppose if you want to extract the digit from left to right, 1 2 3 4. Okay, so these are the basic problems. In this lecture, we will see how we'll develop algorithms for these three tasks. So what we need to understand is, suppose if we have a counting digits, our first problem is counting digits. Okay, suppose if we have 1 2 3 4 as a number, we need to get answer as 4. Number of digits are 4. Okay, so how do you get it? So basically we will use the integer division. Integer division. For example, if we do 1 2 3 4 modulus 10, what will be the quotient? Quotient will be 1 2 3. Okay, if you do 1 2 3 division 10, what will be the quotient? Quotient will be 1 2. If you do 1 2 division 10, the quotient will be 1. If you do 1 division 10, the quotient will be 0. So how many times you have done this division? So 1 2 3 4. So this process will give you. So we need to keep dividing the number by 10 until we get a 0. Okay, we keep on updating the number. So we need to divide the number by 10 until the number becomes 0. Okay, we keep updating. For the number is 1 2 3 4. Next number will be 1 2 3. Next number will be 1 2. Next number will be 1. Next number will be 0. There we will stop. So how many iterations, the number of times we are dividing, okay, that will be the number of digits of a number. We are only handling the integer numbers. We are not worrying about the decimal numbers, only integer numbers. This is applicable only for the integer numbers. Let us try to develop an algorithm for this. So algorithm, do it in another color. Algorithm, then count digits. Input, then number n greater than 0. Okay, integer, it basically integer number. Number, what will be the output? What will be number of digits? Number of digits. Digits of n. Yes. So begin. Begin. So input n, we need to read the number n, input n, and we need to do input validation. If n less than or equal to 0, then output invalid input. invalid input, stop the program. So this concludes the if statement and if. Otherwise, what we do is we need to count the number of digits, right? So we need to take a variable count. Count equal to 0, whose value is in default 0. What I told you, so we need to do division by 10 as long as n is greater than 0. So that is why we are keeping a while loop. While n greater than 0 to n equal to n division 10. Okay. Count equal to count plus plus. I am doing count plus plus. Count plus is basically count equal to count plus 1. Okay. And while. So this is basically we are doing integer division. N we are talking about n by 10. So it's we are talking about integer division. Okay. So how do you take this? Let me erase this and rewrite again. Absolute, not absolute value. We need to take round off n by 10. So this will give you quotient of n by 10. So, okay. So in programming languages, by default, if you are doing integer by integer, that is the output will be integer. Suppose if you are doing a 10 by 3, the output will be 3 because this is integer, this is integer. Integer will be integer only. Integer by integer is integer only. It will discard the fractional part. So, but since you are writing an algorithm, we should make sure that this n by 10 is rounded to the closest. No, it's not rounded. I think it should be floor of floor, floor of floor, floor of n by 10. Okay, floor of n by 10. So count plus plus. So what is see what is happening? Initially n is, for example, you take 1 2 3 4. Initially n is 1 2 3 4. When you do n is equal to n by 10, it will be 1 2 3. The count becomes 1. So and again next iteration, count by 1 2 3 by 10 is 1 2 and 1 1 and 0. So this loop runs for 4 times, and then count will incremented by 4. So we just need to output count here. You understand? This is the algorithm. Okay. So we can write is equal to n equal to n by 10 also here, because usually in programming languages, integer division gives an integer value. So we are just discarding the fractional part. Okay. Yeah, this computes the number of digits of a number. Next is how to extract the digits from right to left. For example, if you have a number 1 2 3 4, 1 2 3 4, we need to display 4 3 2 1. We need to extract the individual digits. First we need to extract 4, we need to extract 3, we need to extract 2, then we need to extract 1. So suppose if we have a 1 0 0 4, we need to extract 4 0 0 1. Okay. Okay, right. So the idea is, suppose if you have a 1 2 3 4, 1 2 3 4, if you do a modulus 10, what you will get? You will get the right mode digit. Okay. And then if you do n equal to n by 10, 1 2 3 4 becomes 1 2 3. 1 2 3 mod 10 will be 3. 1 2 mod 10 will be 2. 1 mod 10 will be 1. So like this, it will be 0. So what we need to do is we need to extract the rightmost digit. We need to apply the modulus operator, and then to discard the to discard the rightmost digit from the number. Excuse me. To discard the rightmost digit from the number, we need to do a quotient operation. Quotient n equal to n by 10. Okay. So let us write the algorithm. So algorithm, yeah, let's write it in different color. Algorithm, digits, digits, right to left. Input n greater than 0, integer number, n is an integer number. Output, output, display digits from right to left. So begin. So, so when very similar to the previous case, we need to input n. So input n. If I think I will copy paste the previous thing. From here, I will take this copy, copy, paste. So this is the algorithm. Okay, this is the part of the algorithm. So this input validation is done. So what we need to do? We need to display the number, right? So y n greater than 0 do y n greater than 0 do digit is equal to n mod 10. This will give me right digit, right? Output digit. So now I need to see, this will extract the rightmost digit of the number. Now I need to discard the rightmost digit from the number. How do I discard the rightmost digit from the number? N equal to n by 10. N by 10. So this is actually equivalent to n equal to floor of n by 10. Okay, so we simply write n equal to n by 10 because we are intended to do a integer division. Okay, and then end by this end. So if you have a number 1024, if you have a number 1024, what happens is so 1024 mod 10 is 4 will be displayed. Okay, then n becomes 102. 102 mod 10 is 2. 2 is displayed. So number becomes 10. 10 mod 10 is 0. So 0 will be displayed and 0 will be discarded. 1 mod 10 is 1. Okay. And then 1 becomes 0. So this algorithm will display 4201 for if the number is 1024. So this is just exactly displaying the extract the digit from right to left. Now let us look at the problem on extracting digits from left to right. Suppose if you have a 1, 2, 3, 4. So what you need to display? 1, 2, 3, 4 individual digits from left to right. This is earlier we just if you done we just done the modulus operator to get the rightmost digit. It was easy, but it's not easy to get the leftmost digit. How do you get the leftmost digit from this 1, 2, 3, 4? So we need to do how many digits are there? 4. 4 means so we need to do a modular quotient 1, 2, 3, 4 divided by 1000. 1000 will give me 1. Okay. And 1, 2, 3, 4 mod 1000. will give me 234. Okay, we need to extract the leftmost digit and we need to discard the leftmost digit from the number to proceed for the next iteration. So this is exactly, this is for 1, 2, 3, 4. What if we have 1, 0, 2, 3, 5, 1, 0, 2, 3, 5. Okay, 1, 0, 2, 3, 5. Then what happens is number of digits are 5. So you should divide with 1, 0, 0, 0, 0, 4 zeros. So it will be 10 to the d minus 1, where d is the number of digits of the number. So initially we should start with dividing with number 10 to the d minus 1. Okay. Yes. So 10 235 mod 10,000 is equal to 235. You see here, suddenly 5-digit number has become 3-digit number. Okay. So this way we will discard 0. So that should be handled in the program. I will explain you how that can be handled. So what we need to do is, first step is count the number of digits. Count number of digits. Let it be d. Let it be d. And then compute 10 to the d minus 1. 10 to the d minus 1. D minus 1. 10 to the d minus 10 to the power d minus 1. Okay. Then perform the division with 10 to the d minus 1 and get the quotient. That will be our leftmost digit. To discard the leftmost digit, we need to do modulus with the 10 to the d minus 1. For the next iteration, the power, I mean 10 to the d minus 1 becomes 10 to the d minus 2. Okay, because the number of digits are reduced by 1. Okay, let us write the algorithm. So algorithm digits left to right, input n greater than 0, integer number, an integer number, output, display digits from left to right. Begin. Let us, so we have input n and input validation. Let us take that from here. This is very similar to here. So that's why I'm okay. Right. Input n. If n is invalid, we will input and stop the program. Right. Then otherwise, what we need to do? We need to count the number of digits first. Okay. Number of digits. So see, when you are counting the number of digits, n will be modified, right? N equal to n by 10. So I want to keep the original n same as it is. So I'm taking a copy of n, n1 equal to n, count equal to 0, count equal to 0, while n1 greater than 0 do. Okay. N equal to n by 10, count plus plus. This is exactly the logic we have used to compute the number of digits. Similarly, we can even compute the power also, 10 to the power. Because this loop runs d times, we can compute 10 to the d easily. Power is equal to 1. So power equal to power star 10, power star 10. So if this loop runs for 4 times, eventually the power will become See, we need to compute the number of digits as well as 10 to the d minus 1. Okay. So, so we will count the number of digits will be carried in the variable count. And then when we say power equal to power star t, by the time this loop computes, the power will have a 10 to the d. So we need to have 10 to the d minus 1, right? Power equal to power by 10. Okay, right. Next, next what we need to do? We need to run while n greater than 0 2. Since we have kept the copy n as it is, we are doing. So d is equal to n by power. N by power. Okay. N by power. This will extract the leftmost digit. This is basically um, n by power. Okay. Then n equal to n mod power. This is basically floor of is equivalent to floor of n by 10. Okay. Integer n by power. Power. Okay, this is an integer division. Okay. So let me put it in the bracket. Okay, this is an integer division. Okay. Then for the next iteration, the number of digits are the number is reduced by 1. Similarly, power should reduce it by a factor of by 10. So power equal to power by 10. Okay. And y. So I think here we should have output d. Output d. Okay. Let us see what we did. So we have read the input n and then input validated the input, and then we have kept the copy of n in n1 because we need to compute the digit first. In the digit computation, we are modifying n, so the original n value should be preserved. That is why I kept n1. Then count equal to 0, power equal to 0. So this logic is to compute the number of digits. This is very similar to the previous algorithm. Okay, the counting the number of digits. But only take is we also need 10 to the d. So that is why we are computing. We are added this sharing power equal to power star 10, where initial value of power is 1. So by the time this while loop completes, so I think, sorry, this should be n1. Sorry, this should be n1. So this should be n1. This should be n1. Right. Yeah. So n1 equal to n1. So by the time this while loop completes, we have a count as a number of digits, and then power will be 10 to the d. But we want 10 to the d minus 1, right? 10 to the d minus 1. So power equal to power by 10. If you do power equal to power by 10, it will be 10 to the d minus 1. Okay. While n greater than 0, do. So what we do, we try to extract the left digit. How do you extract the left digit? D equal to n by power. N by power will give the leftmost digit. And then output the digit. And then how do you get the number discarding the leftmost digit? N equal to n mod power. Then for the next station, power should reduce it by 1, 10 to the d to 10 to the d minus 1. Sorry, 10 to the d minus 1 to 10 to the d minus 2. So if you do power equal to power by 10, it will be 10 to the d minus. For the next station, it will be 10 to the d minus 3, like that. Eventually, we'll extract all the digits as long as n becomes n when n becomes 0, so it's already extract all the digits and displayed them. Okay. Let us see the algorithm. This is the count digit program, the algorithm for count digits, and this is the algorithm for displaying the digits from right to left. As I told, algorithms is small d, small n, capital N. Algorithms are case insensitive. Okay, they are not small n, capital N are same. When it comes to programming language, it is case sensitive. So you need to make sure that this n and this n should be typed in the same case. And this is the algorithm to compute the number of digits from left to right. Okay. Okay. One issue I need to tell you is this algorithm is slightly have an issue because of for this case it may not work. This case may not work because it will not display the zero. So that is why what we need to do is instead of running the algorithm for while n greater than 0, what we need to do is we need to run the algorithm for d times, where d is the number of digits. Okay, so d. Okay, right. So let me modify this while condition. So while while count greater than 0. Okay, so count should be incremented. And so this should be here, end. Okay. This way, is what happens is this loop runs for the d times. So when you have this 1024, 10235, what happens is when you do a 0 to 35, what you get is, I think the original algorithm works okay, fine. So this runs instead of, because we want to display all the digits zero also. So that's why we are running this liquidation for d times. Okay. Yeah. So yes. Yes, so this is algorithm. This loop is to compute the number of digits on the 10 to the d minus d. Then this power equal to 10 to the d minus 1, while d greater than 0, d. While d greater than 0, d is the number of digits. So d greater than 0, ms most equivalent digit is extracted, output most equivalent digit, n equal to n mod power equal to power by 10, d equal to d minus 1. So exactly the same. This loop runs exactly d times because the number had d digits and all the digits are displayed from left to right. This concludes this lecture. Thank you.